Okay, so this is my first attempt at a video to try and teach you guys a little bit of physics. The video might be a bit crap, just let me know what you think, but hopefully this might give you a bit of a hand when it comes to trying to learn the ins and outs of radioactivity. So we're going to start a newer part of the topic today, following on from the work that you guys have done on the structure of the atom and the history of the development of the atom, where you started looking at Rutherford and his gold sheet and alpha particle experiment. So we're going to actually start to look at those alpha particles and what that all means. Before we do that though, we've got to actually look at what constitutes a radioactive element. And to look at a radioactive element, we've got to start studying the nucleus, because this is where everything happens. So we're going to start by looking at what makes something either stable or unstable. And I'm assuming that you all know what stable and unstable means. So this basically means that it's okay, it's fine. And this means that it's not great, could fall apart at any minute. You know, some of you might be thinking, oh, it sounds like me. But, you know, you all know what I'm talking about. So stable and unstable nuclei. So what I've done to start with is I've drawn a really basic picture of a nuclei. So it just so happens that I've done 3 protons and 4 neutrons. And if you can work it out before I say it, well done. That is actually the nucleus of a lithium atom. It's purely by chance that I drew 7 circles and came up with lithium. It doesn't have to specifically be lithium. Anyway, so in our nucleus, we have got P and N. So P is representing our protons, which have a positive charge. Our N's are representing our neutrons, which have no charge. They're neutral. And hopefully we can all remember this. Okay. The positive protons are still quite clustered together. Yeah, they're broken up a little bit by these neutrons, but at the end of the day, the protons are close to each other and they have the same charge. So if each proton has the same charge, then what you would expect is for the protons to repel one another, because they have like charges. And you should remember from when you learned about magnetism way back in year 8 that like charges repel. Or rather I should say like poles repel, so like charges repel. Anyway, so we'll write a little note on that. So like charges repel, so protons should repel. Okay, so because those protons should repel one another, then technically speaking, nuclei should be unstable. Any nuclei should be unstable, and a nucleus would explode because of the repulsion from the protons. So like charges repel, so the proton should repel. So this should make a nucleus unstable and therefore explode. But it doesn't. It doesn't explode. So because it doesn't explode, then that must mean that there is something else preventing the nucleus from exploding, and that there must be another charge in the nucleus, sorry, not another charge, another force in the nucleus making things stable. And there is another force, and this force is called the strong nuclei force. It's very, very simple to remember, the strong nuclei force. And this is actually holding the nuclei together. So the strong nuclei force is present in the nucleus and it prevents it from exploding. Okay, so that's the first thing that you need to know about why a nuclei is okay, why it doesn't explode. Okay, so this is the reason why it's staying stable or relatively stable, and it's not just going to blow up. So, like, you know, because if all atoms just blew up, well, then we wouldn't have existence, would we? Let's face it, because everything would be unstable. So the strong nuclei force is responsible for keeping everything held together. Okay, so this strong nuclei force, it provides a force against the repulsion. So it basically like opposes the repulsion of the protons. So the strong nuclei force opposes the proton repulsion. So it opposes the proton repulsion. And we call that binding energy. Okay, so that's called, excuse me, called binding energy. Okay, so now we can look at the difference between a stable atom and an unstable nuclei. So what makes something stable and what makes something unstable. So now we're going to take into account the strong nuclei force and the binding energy. So now that we know that the strong nuclei force is what's keeping it from exploding, and that's creating this thing called binding energy, so stopping the proton repulsion, now we can think about what makes something stable in terms of binding energy and what makes something unstable in terms of binding energy. So two options. We have got a stable atom, and we have an unstable atom. Okay, so two options. So if your atom is stable, then that means it has enough binding energy to permanently hold the nucleus together. So a stable atom, so anything that's small, so any small atoms, and I know that sounds silly because all atoms are small, but I mean things like, let me look at my periodic table, things like hydrogen, lithium, beryllium, anything early on in the periodic table that's only very small is going to have a very strong binding energy, so it's going to be a stable atom. So a stable atom, any atom that has enough binding energy to permanently, I can't spell, permanent hold the nucleus together. Okay, so there's our stable atom. So what's an unstable atom then? Well, as you can probably imagine, it's an atom that doesn't have enough binding energy to hold the nucleus together permanently. So because it doesn't have enough energy to hold the atom together permanently, hold the nucleus together permanently, it starts to decay. And this is where the idea of radioactive decay comes into this. So we're starting to link together different ideas. So stable atom, anything that's got enough binding energy to permanently hold the nucleus together. But an unstable atom is an atom that cannot generate enough binding energy to permanently, I spelled it right this time, permanently hold the nucleus together, and so it begins to decay. So I'm just putting that, oh, I've gone off the screen. I'm just putting that in capitals there purely because you can see now that we've started to think about something else. So this is literally, I'm just going to go up to here with this first video just to see how this turns out. So we've got our protons, which have got a positive charge, and neutrons, which have got no charge. So what you would expect in a nucleus is that the protons repel one another and that they start to push away because they have like charges. But it doesn't happen. The nucleus doesn't explode. This is because of the strong nuclei force, and that's present in the nucleus. It stops it from exploding. The strong nuclei force opposes the proton repulsion, and we call this binding energy. Okay, so the binding energy that keeps the neutrons and the protons close together is created by this strong nuclei force. If you have a stable atom, then that means that that atom has got enough binding energy to permanently hold the nucleus together. So it means it will permanently keep those protons and neutrons together. But an unstable atom is an atom that can't generate enough binding energy to permanently hold the nucleus together. So it begins to decay, it starts to fall apart. And in nuclear decay, we lose neutrons. So it's all about looking at what happens with these neutrons and what happens with our protons. So what happens when the atom starts to fall apart. Okay, so that is the end of video 1. And that is our quick introduction to a stable atom and an unstable atom. And then video 2 will start to look at what happens when we have more neutrons than protons and why we get this decay.